The video for section 8.3, we're going to talk about hyperbolas today. This is the last of our conic sections. Hyperbola is formed if I do a cross section of my two cones in a vertical manner. And so you can see, if I cut the cones going down this way, then I end up with essentially two parabolas. Because now, because I went vertically, I'm cutting through both napes. So, what is a hyperbola? It's the set of all points in a plane whose distances from two fixed points in the plane have a constant difference. This is very important that it's a difference. When we talked about ellipses, they had a constant sum, which means it was a plus. And if you notice on your formula sheet, the formula for an ellipse is a plus. The only difference between the formula for a hyperbola is that it's a minus. And now, when we're talking about hyperbolas, A does not have to be with the bigger letter. So the bigger A does not distinguish which way my hyperbola is going to open. Whatever comes first in the equation is how my hyperbola will open. So that's a little bit different from the ellipse. And you'll notice that we still eat the foci. The foci is still inside of the graph. And in this case, both parts of the graph. So before, our vertex was out here, and we were going like this to get our ellipse. Well, now, my vertex is on the inside, and I'm turning outwards because I'm subtraction. So an ellipse is inside, and it's a plus. Hyperbolas are outside, and it's a minus. So some vocabulary. We have the exact same vocabulary for hyperbola as we do for ellipse, with the exception of eccentricity. And eccentricity is the ratio of C to A, and it's how off-centered the foci are. Okay, and it's kind of an odd kind of thing to think about, but you really just need to know that it's the ratio of C to A. So our formula for that is going to be E equals C over A. And you need to write that on your formula sheet for hyperbola. E equals C over A, so that you have it. But we still have our focus, our vertex, and our center. You will notice that essentially the focus and the vertex have flipped places from the ellipse, because now my graph is opening out instead of in. And remember, the graph always eats the focus. So, formulas for hyperbolas. Notice they look pretty similar to our ellipses. Some things I want to point out. First off, we said there's a minus sign here instead of a plus. So that's our big difference. How do I know which one I'm using? Look for the plus and the minus. The next thing you'll see is our Pythagorean relation is back in business. C squared equals A squared plus B squared. So it's our normal Pythagorean theorem that we've been looking at. Everything works out nicely. You'll also notice we have the addition of our asymptotes. Okay, and we'll talk about those in just a few minutes when we get to drawing our graph. But we also now have eccentricity, and you need to add that to your sheet. E equals C over A. And instead of having a semi-major and a semi-minor, because they don't dictate what's going on, we have a semi-transverse axis and a semi-conjugate axis. That's what A and B represents. So, what is the difference between the equations for an ellipse and the equation for a hyperbola? Go ahead and take a minute and think to yourself. The difference is a hyperbola has a minus sign. Otherwise, they look exactly the same. Right? And what do they look like? This is what they look like. Alright? Over here, I'm opening out along the x-axis. Over here, I'm opening up, which means I'm following along the y-axis. So, find the center, vertices, and foci of the hyperbola. Center, vertices, and foci. Okay, so we want to know center. So first thing I need to find is my center, and that's my h comma k still. And so for our first example, because I'm not adding or subtracting anything from x, my center is 0, 0. And because x came first, this is an x squared equation. Alright, because x came first, this is x squared. So it has nothing to do with which denominator is bigger. That's ellipses, not hyperbolas. So, hk, h is 0, k is 0. Now I need a, b, and c. So, what is a? A is the square root of what's under the first term. B is the square root of the second. So the square root of 16 is going to be plus and minus 4. B is the square root of 36, which is plus minus 6. Then I got to go to my c. Remember, c squared equals a squared plus b squared in this case. So c squared equals 16 and 36, which is 52. So c is plus or minus the square root of 52. So let's go back to finding our values. Alright, for a hyperbola with an x squared, x is first. To find the foci, it's h plus or minus c. So foci, 0 plus or minus the square root of 52, comma, k, which is 0, which means I got square root of 52, comma 0, and negative square root of 52, comma 0. Okay. For vertices, it's h plus or minus a. So 0 plus or minus 4. Keep doing it. Comma 0, which is 4, 0, and negative 4, 0. Final answer. So I have my center, my vertices, and my foci. Go ahead and pause the video and see if you can find all three parts for the next example. And go ahead and check your answer. Remember, this is a squared, b squared, and then c squared is 9 plus 49, which equals 58. Undo the square. C is plus or minus square root of 58. So next we got to figure out how to graph hyperbolas. Now, a couple of things I want to point out, and the reason for this graphic. This is an x squared. Notice how an x squared is essentially eating the x-axis. A y squared will eat the y-axis. We still make this box like we did last time. Okay, A and B are still going to set up my box. Then, I'm actually going to draw in these asymptotes, because there are asymptotes in a hyperbola. It gets really, really close to this line and then turns away from it. So we'll talk about how to do that next. So, sketch the graph of this hyperbola. A couple of things you need for your hyperbola. First off, you do need to know your center. In our case, the center is 0, 0. A is plus or minus 2, and B is plus or minus 3. Now remember, A is with the y in this case, because I have a y squared first. So when I go to label this, so I'm looking at the equations on the right instead of the left now for my hyperbolas. So now my vertices are going to be k plus or minus a, which means I'm going on the y-axis. So on the y-axis, I am going to go up 2, and this is going to be a vertex, and I'm going to go down 2, and this is going to be a vertex. I am centered at the origin, 0, 0. Now I still need to label my foci, so I'm going to go ahead and find C. So 4 plus 9 is C squared. C equals the square root of 13, which means C is 3.6 approximately. 3.605, but about 3.5. So from 0, I'm going to go a little over 3.5 out. That's my focus. Also here, a little over 3.5, and that's a focus. So I have all my parts labeled, and they run along the y-axis because y came first in my equation. Now, how do I draw my hyperbola? So, first thing I need to do is create my box. So my box goes through A, and A was 2 at my vertex. So here's my box. First part of it. And this is plus or minus A. Then I gotta figure out plus or minus B, and I'm gonna go out 3 from B. So remember, this was B, negative B, A, negative A. Okay, so I have this box. Now what I need to do is I need to draw a line through the diagonal of my box that also goes through the center. Okay, these are my asymptotes for my graph. So once I have my box and I have my asymptotes in place, I go to my vertex and I sketch my graph out following along my asymptotes. And there's the graph of my hyperbola. Okay. So take a minute to think about what's going on. Pause, make sure you have your graph sketched correctly. And it should make sense because my graph is eating the y-axis. Well, y came first in my equation. So that part should make sense. In this example, notice that x squared comes first, so we're going to be working on the x-axis. Our center is 3, negative 1. So now when we're counting, we need to count from our center. A is plus or minus 5. B is plus or minus the square root of 6. C squared equals 25 plus 6, which means C equals plus or minus square root of 31. And we're going to want those decimal values, so go ahead and find those. So C is about 5.5, 6, 7, and B is 2.449. Remember, that's plus or minus. So now that we have all of our information, we need to plot our points, our foci, our vertices, and our center. So first thing, plot our center, over 3, down 1. This is our center. From there, we need to count our A. That's going to be plus or minus 5. So remember, this is an X, so we're going along the X. Here's a vertex. Go 5 the other way. Here's a vertex. And this creates part of our box, don't forget. Okay. Then we need to go plus or minus B, and the B's are going to go up and down. So from the center I need to go up about 2.5. This creates the rest of my box. Okay, so I have my C, I have my V, both of my V's. Now the only other thing I need is my foci, which means that from that center I need to go out 5.5, which is actually just beyond, a little bit beyond my vertex. So my foci is not much bigger than my vertex this time. Now, create those diagonals so we get those asymptotes. And you will have rulers, so make sure you use your ruler. And then this is on. So my graph goes from my vertex, and it's going to curve out along my asymptotes. Okay, so we have to pay attention to which comes first, x squared or y squared. That tells us which way our hyperbola is going to open. Now, we're going backwards. We're sort of following the same order we did in the last two sections. We identified our parts, we drew our graph, and now we need to write the equation. Remember, this time we have a minus between our x and y. So, our foci here is at 5, 0. So if I think about drawing this guy out, I have a foci here and a foci here, which tells me that this is an x squared equation. So I know that I need to use my equations on the left. So now we have our focus. We're looking for the transverse axis. And if you notice on your sheet that it's the semi-transverse axis. So again, it's half. So A is 1.5, because that is half of 3. Remember that semi means we take our length and we divide it by 2. So, if A is a half, then from my foci, I need to go, from my center, I need to count out 1.5. So here's my center. Go 1.5, 1.5, and these are my vertices. Now we also know that C is the distance from the center to the foci, and so our C is 5, which is going to help us find B. Remember, our Pythagorean relation is C squared equals A squared plus B squared. So B squared is going to be 22.75. Now, because we don't need to find B, we're not graphing, we're just writing the equation, we can leave it as B squared. Remember, our H is 0, K is 0, and we're on the x-axis, so that means we're going to use an x squared equation. So, our equation is going to be x squared over A squared. 1.25 squared was 2.25. Minus, because it's a hyperbola, y squared over b squared equals 1. And that's our final answer. So we're still, just like we would with ellipses, we're still trying to find HK, A, and B. Let's go ahead and check out the next example. So the transverse endpoints are at 5, 3 and negative 7, 3. So negative 7, 3.
Amanda?
Then 5, 3. Now, this is the endpoint of our transverse axis, so these are our vertices. Okay, and because our vertices are following a horizontal line, this is an x squared equation. And we have to find our center. So we figure out that from one vertex to the next is a total distance of 12, which means halfway through it is 6. So our center ends up here. That makes our center at -1, 3. So now we have h equals -1, k equals 3. We need a and b. Well, the distance from the center to a vertex is a, and that distance was 6. Now, the other information they give us is the conjugate axis length is 10. So the distance from here to here has to be 10. Well, half of that makes it 5. This distance is 5. So that tells us our B. B is 5. And now I can write my equation. I have x minus h, so minus -1 becomes +1 squared over a squared, so 36, minus, because it's a hyperbola, y minus k squared over b squared, 25, equals 1. And that's our final answer. So we need to draw our graph. We need to understand kind of what's happening with the information that they give us in order to write our equation. Here are 2 examples. Go ahead and pause the video and try to write the equations on your own. Then come back and check your answers. One thing to notice is there is a typo here. That should be a -9. Go ahead and check your answers. Now, please ask the teacher for the exit ticket. Go ahead and answer those questions, and then move on to your homework.